Hello and welcome to SciFiDevCon. My name is Sarah Dukevich, and I'm going to give you an intro to graph databases using Gremlin and exploring the themes in Mystery Science Theater 3000. So let's go! Some things to watch out for today. We're going to take a look at the data and how did I get at this data. Then we're going to talk about how do we use this data to model our data to fit in a graph database. We'll talk about the graph database components and some terminology to be familiar with. Then we'll look at our Azure Cosmos DB Gremlin API, and then finally we'll look at some Gremlin queries. In honor of SciFiDevCon, I chose the theme to look at Mystery Science Theater 3000 and some recurring themes. So let's take a look and see what I found, but first, how did I get this data? Where did it even come from? Searching for data for Mystery Science Theater 3000 proved to be very difficult, so I ended up creating my own data. The episodes we're looking at are from the late 80s to the late 90s, and the abstract for this talk, I promised princesses, dinosaurs, and kaiju. There are also a few other themes included. Now when it came to forming this data, I had to figure out where am I going to get the data from, and then once I looked at the data, what themes did I want to include? And then finally, I had to encode my data so that I could actually work with it in a different format. I started out with MST3K.com, because they have a great episode list, so I could see the episodes, the seasons that they appeared in. I could read the abstracts for those and gather some of the different themes from there, so that this was all done manually. And then I looked at Wikipedia for the air dates, because I thought I was going to use the air dates. It turned out I ended up not using them, but so you're aware I grabbed them during data gathering. Now to be clear, I'm using just the episodes from MST3K. I am not including the Mystery Science Theater 3000 movie. So this is a sample of the data that I'm working with. Yes, it's an Excel document. When I'm gathering data, I tend to start with a table, and then from there I disseminate as needed. For our data, we have an episode number, we have the movie, the air date, the season, the channel. So is it on Comedy Central, was it on Sci-Fi, or was it on KTMA, which is what season 0 was on. And then you'll notice a lot of the columns with zeros and ones. Those are the one hot-coded columns. Basically think of it as I've got a category and it's either it has that category or it doesn't have that category, so 1 or 0. And this is how I worked with it. You'll notice, for example, that King Dinosaur does not have any relationship to princesses or princes or kaiju, but it does happen to have dinosaur. Now, yes, I start as a table, but then I have to think about how am I going to organize this in a way to look at it on a graph. Graph databases are great for looking at relationships of things. They're used in fraud detection, they're used in understanding social networks, perhaps understanding computer networks, recommendation engines. So you know when you're shopping online and they're like, you know this thing you might also be interested in? We could take something similar where you like this particular theme, perhaps you're interested in these other themes. Keep that in mind. We will come back to that. So with graph database modeling, you've got to think of how are we going to use this data? We need to think about how are we going to query this data. That tells us how to organize our properties a little bit more. We could take a look at how often are we going to be updating it. If we're not going to be updating our data, we may structure it differently than if we would be updating a property all the time. And then we also need to understand the system that we're going to be working with our graph data, and how is it getting stored, and what does that system support. So for our data, we've got two entities, episode and theme. We have the relationship of contains. We're going to be storing this in Azure Cosmos DB. And since we want to work with graph data in Azure Cosmos DB, we also will be using the Gremlin query language. But before we can get into the querying, we need to understand some terminology first. So we're going to talk about entities. Entities are also known as vertices. Singular one is a vertex. Think V for vertex. Vertices can have properties. You'll see vertices also have labels. Labels are what identifies what kind of thing they are. So our labels are, in this case, theme and episode for our vertexes. The episode vertex also includes various properties, including episode number and channel. Our relationships, on the other hand, those are our contains. So contains in our relationships is their label. You could also have properties, but for what we're looking at with relationships, properties don't matter. They don't enhance the relationship understanding any further, so we're okay with just keeping it as contains. Relationships are also known as edges. Think of them as E for edges. The V for vertices and E for edges will come back when we look at the queries. But then we've got things, we've got relationships, and we also have relationship directions. Those arrowheads are key. They point either in or out. So we're going to take a look first from another theme. So we saw princesses. Now let's talk about dinosaurs. We have Future War, Godzilla versus Megalon, Godzilla versus Sea Monster, King Dinosaur, even the Legend of Dinosaurs from Season 0. All contain the dinosaurs theme. Notice that those arrows are pointing at dinosaurs. They are coming into the dinosaur's vertex. So when we come at the vertex, those arrows pointing in, those are going to be known as in E. We'll see that in the syntax. Out, the arrows are pointing outwards from the vertex. So Godzilla versus Megalon, it contains the kaiju theme, the giant theme, dinosaurs theme, and aliens theme. Notice that those arrows are pointing out from the episode. Those are going to be out E, or out edges. Edges and vertices both have in and out. We will look at those in our queries. But before we even get to our queries, let's talk about Azure Cosmos DB Gremlin API. What is that? So Azure Cosmos DB Gremlin API, this is what we're going to use to access graph data that is stored in Azure Cosmos DB. So Azure Cosmos DB, think of the data as stored as schemaless JSON. The APIs allow us to query it using various different query languages. For example, there's Cassandra with its CQL, there's MongoDB with their query syntax, but the one we're focusing on is Gremlin API. Why Gremlin API? That's the graph database implementation for Cosmos DB. We can query in the browser with Azure Data Explorer. You can also add to a graph with Azure Data Explorer, but because we have so many different vertices, so many different nodes, I ended up using Python, using one of the API libraries. But for our demos, all the queries I show in these demos can be run through Azure Data Explorer. Now, when I run the query, how does that work? So I go to Data Explorer from the left-hand side on my Cosmos DB account. Then I will select the palette icon. It also will have the word style if it's a large enough screen. And then you'll select the name for the vertex, because when you first go to a graph, it shows IDs, which aren't helpful for what you want to evaluate. So we change it to name so we know what our nodes clearly are. And then we'll change the property node color to label. That way with themes are a different color than our episodes. Then go ahead and select OK. Now let's talk about Gremlin before we get into the queries. What is Gremlin? So Gremlin comes from the Apache Tinkerpop project. It is a procedural language which does pipeline execution, so it's going to be read from left to right. It has various support for the language in other languages, so you can use Gremlin with Java, Groovy, Python, Scala, C#, and more. So what are the steps that I took to load? First, I logged into my Azure account. Then I created Azure Cosmos DB Gremlin API Azure resource. I added a database called SciFiDevCon with the collection name of MST3K. And I added a partition key called type. Now, why did I choose type? Partition key will tell Azure Cosmos DB to store data of a similar partition key together. You can't use ID and you can't use label, so you need to use some other way of organizing your entities. I could have done it by season if I wanted to evaluate only a season at a time, not avoiding cross-partition queries. But in this case, for our demo, we're using type. Now, once I do that, then I can download the starting Jupyter notebook, which I've already created, and I will make available on GitHub. Then I'm going to update my connection details with the values from my Cosmos DB, and then I'm going to run my Jupyter notebook to load that data into my Cosmos DB Gremlin API. Once that's there, some things to note with loading my database. So I'm going to read in my Excel sheet using pandas. I'm working in a Jupyter notebook that I created using Azure Data Studio. I'm going to use Gremlin Python to connect to the Cosmos DB Gremlin API. I will create my vertices and my edges. And so once we do that, then I run this piece of code here that is seen on the slide, which shows the client, and it shows cleaning up the graph. So I get rid of all the edges and get rid of all the vertices, and then start from scratch and insert the new vertices and new edges. Typical demo setup. Right, when it comes to the vertices, so when we do Gremlin queries, our queries start with G. Think of G as the graph. The graph is the collection of your vertices and edges. So G.V gets all the vertices for the graph. G.V.hasLabel episode, I only want the episodes, so it would give me that collection. And then G.V.hasChannel KTMA, so perhaps I only want all the vertices that were aired on KTMA. Notice hasLabel. Let me show you. So with hasLabel, this is going to look specifically at that label field. We have two different types of labels in our data set right now, episode and theme. Has allows us to look at properties of a specific value. So this is using channel KTMA. In our screenshot, we have channel Comedy Central. So you could see that we could do filtering by any of these different properties using has. If we want to filter on label, we can use hasLabel. Now, when we're working with Azure Data Explorer, we have visual abilities for graphs when we're working specifically with vertices. So this particular screenshot you see here shows the kaiju theme, and you can see all these different episodes that are pointing out to the kaiju theme, or you can say you see the kaiju theme and all these relationships are coming into it. Another thing you'll see in Azure Data Explorer is the properties. In the properties, you're going to see the name of the node. You're going to see any properties associated with the node. And then you'll see the sources. The sources are where you're getting the relationships and what kind of edges are they coming in. There's sources and there's targets. So kaiju is got the relationships coming into it. The sources are on the other side. So those are your out. And so this is what you're seeing here is like Godzilla versus Megalon and Gamera. They all contain kaiju in their movies. Now, edges are the relationships. E for edges, V for vertex. You see why I said that earlier? Now, G again, we specify G as the whole graph. G.E, with the open and closed parentheses, gets all the edges. You could also do hasLabel, and you could also do has with properties, but because we don't have any properties on our edges for this demo, I don't have that here in this table. But you can use .has with the property filtering as well. When it comes to edges, there's not a cool way to see these edges. Unfortunately, you're stuck with JSON. They're available. The JSON response does come back for both vertices and edges. For edges, that is the only option. You'll notice here that we have various fields. We talk about the in and out. Notice in V's because we're looking at edges, and out V's. So we have a episode and it's going into a theme. Now, edges is sources. So we're taking a look at the princess's theme. And notice that we have, there's the sources here. We've got the magic sword and the cosmic princess. Their relationships are going into the princesses. So these are going to be known as sources. Now, edges for the princess is vertex. Some things to note with those in the JSON. So notice here that we've got the label contains. The contains does not show in the graph rendering. However, you do see that, okay, this is a type of edge, and you can see in V label, out V label, in V, out V, things like that. In V label is where is it coming into, and the out V is where is it coming out of. Now with Gremlin, it's written in red, left to right. When you see me put query parts on the next line, just assume that it goes in a straight line across. I just had to make it a little more readable for us to follow here. But we'll see a statement as a pipeline. It starts with G, and then you're going to be traveling either through vertices or edges. You start with one collection, and then you decide from there which direction you want to go, in, out, or both. When you're doing graph traversal, it might take a while to get used to the ins and outs, and so it might help to draw it out. I'm going to break it down. Let's look at vertex, and then we'll look at edge. So vertex. What should you know about vertices? when we're looking at a vertex, we're going to look at princesses for this example. It has NE. Why does it have NE? Because there are arrows pointing at it. It has relationships coming into it. If we do G.V, so get all the vertices that has the name princesses, and the NE, that will come back with 2 edges. If we do out E, there should be 0 edges because there are no relationships coming out of that princess's node. Now if we look at, say, the magic sword, it will have an out E because the edges are going out of it to princess. Pay close attention to the way the arrows are pointing. The arrowheads make a difference. Now when it comes to the edge perspective, so you're looking at it from the edges from princess. So we have the edges that are coming in. The NV label, the NV. So the NV label and the NV. So the NV and are the IDs, the NV labels, what kind of things are pointing at it. So we have our theme, the NV, it's being, the arrow is pointing at the theme. Out, where is it coming from? It's coming out from an episode. Now some other queries you might want to run with Gremlin are things like, how many unique labels are there? So let's see how many unique labels are there for the vertices. And so you call g.v.label with open and closed parentheses, and we'll get you your collection of all the labels. Because we want uniques, we can use dedupe. So .dedupe, open and close parentheses, and you'll see that your result will come back as episode and theme. You could do the same thing for edges and their labels. You can also do unique values for a label going into the values for that label. So for example, what are the unique values for the themes? Well, you can do g.v.hasLabel theme. So now we're looking at the vertices that are just the themes. .values will get us the values of those nodes. We don't need all the other properties. We just want the values for the theme, for its name, and then dedupe. And notice that our response will come out with dinosaurs, princesses, kaiju, teenagers, a giant, and aliens will also appear in there as well. Then unique values for our property. So if you want to go even more specific and see, well, what channels are these episodes available on, we could do g.v.hasLabel episode, so just give us the episodes. .values channel, we're only looking at that channel property for these episodes. .dedupe, we want it unique. Notice we come back with Comedy Central, Sci-Fi Channel, and KTMA. Now let's touch on adding edges and vertices. If you want to explore more on your own, you can also add more themes. So when you add a vertex, it's g.addv, in parentheses, you put your type of label. Then you can chain properties by going .property, and in the parentheses for property, you put the property name, comma, and then the property value. Now for example, let's say we wanted to add a space theme. So we would do g.addv theme in the parentheses, then .property, the name is space, and then our property .type is theme. So the type we have to include because that is our partition key in this example. Now we're also going to add an edge. The edge that we're going to do is we need to say, where is this starting from? Where is this going to? We're going to use the movie Teenagers from Outer Space, and it contains a space theme. So first, let's get our Teenagers from Outer Space. So that's g.v.hasName, Teenagers from Outer Space. Now we want to add an edge, so that's .addE. What's our label for the edge? Contains. Now are we going to or from? We're going to the theme. And where's the theme? The theme, now we have to do the g.v query to get to the theme. So that's g.v.hasLabel theme.hasName space. Now you might be wondering, could you have done just g.v.hasName space? In this particular demo, yes, because there are no movies or no episodes that are called space. However, to be more specific and more clear that we want the theme namespace, that's why I included the hasLabel theme first and then filtered on the name. So let's take a look at our new vertex and new edge. Notice now we have Teenagers from Outer Space. Teenagers from Outer Space is an episode, and it now has 3 targets, So targets are what happens when you're going out. So coming out of the teenagers node into the other nodes, or coming out of the teenagers vertex to the other vertices. Its targets are aliens, teenagers, and space. But there's more we can do in Gremlin, so let's look at those. Suppose we wanted to take a look at the number of episodes by season. We can do aggregation. So we could do, for example, to get our episodes, g.v.hasLabel episode. To group, we do group, and then open and close parentheses, and then dot, and then by open and close parentheses. And within by, we're going to say, what do we want to group by? Which property do we want to group by? So we're going to group by season. And then finally, we have another dot by, and in that by, we have values, name, dot count. Now, we want the name value, we want the count for each of those names, and then we'll group that by the season. So that's how that is read. You'll notice here that we have the seasons from 0 through 10, and the ones that are most popular have 24 episodes, so that's seasons 3, 4, and 6. How many episodes do we have total in this data set? We have 195, and I got there by doing g.v.hasLabel episode.count. If you're concerned about the order when you're working with your graph data, you can do an order by. Order by and group by both notice that the verb is got open and close parentheses, and then the by usually has what you're doing the grouping by or the ordering by. So ordering the episode names by name, so specifically we're looking at just the values. We're going to go g.v.hasLabel episode, order by the name, and then just get the values, so dot values, and then the property name is name. If we want the first 5 episodes, we can add a dot limit and the number of things we want to limit. So in this case, dot limit 5. If you want to order by episode number, we could do g.v.hasLabel episode, order by number. So you have ordering. We have looked at filtering. Now we have filtering and ordering, so you can do things like order by channel, then episode number. What does it look like ordering by multiple fields? The key here is that there are 2 bys after order. It's not order by and then another order by. That would reset the system and be like, okay, we're going to order by channel. No, now we just want to order by number. You do order by channel, by number. Now it's going to order by both of those fields, respectively. Suppose we wanted to see season 0's episodes ordered by episode number. You could see it, the way I filtered it down is g.v.hasLabel episode has season 0 order by number. So you can have your filtering and then do your ordering. Again, the order matters from left to right. Now when it comes to, say, like we like the space theme, and now we want to see what other themes I might like. This is where we start getting into the recommendation engines. Now we need to start traversing the graph a bit more. So the way we're going to do this, let me grab my laser pointer to walk you through it. So suppose we like space. Well, space was that new node that we created for teenagers from outer space. Well then, how do we get to these other nodes that are connected to teenagers from outer space? We really like that movie, and now we want to take a look at the other themes, perhaps. Well, we have to traverse it, and the way we do this is we start with g.v.hasNamespace. So we start at space, in.e, so any of the edges that are coming to it, so that's this edge here, coming out of teenagers from outer space going into space. So we're on the edge on the in.e. So the out v, that's where is that edge coming out of? Well, that's teenagers from outer space. Does teenagers from outer space go out or in for the other themes? Well, it's going out, so that's why we do an out E. Then we go to in-v. So that final in-v takes us to aliens, space, and teenagers. So if you like space, you might also still like space. But you also may like movies that include teenagers or that may include aliens. Now you can keep an idea of that path if you're querying about that. If you add .path at the end of that query, it will tell you the path you took to get there. The other thing that you want to probably see is the execution profile. So how is this behaving? What steps does it take? So in order to do that, you could run your query and put a .execution profile at the end. Now, You may see that it comes back in JSON and wonder if you can do more filtering off of that. At the end of execution profile, that's where it stops. You can't add more to your query after the profile to do the filtering. So when we do the execution profile, you can see that the results here show something like the query that was run, the activity ID, how long did it take to run, the total resource usage, and any metrics. Those metrics include things such as the times, the counts, and any storage details associated with that query. So this particular query, we're getting our vertices. That's what g.v is. The in edges, that's your get edges. Get neighbor vertices is out v. Get edges is your out e. Get neighbor vertices is in v. And then your project operator, that's your execution profile. So you could use this to see how effective your queries are using the Gremlin API. Now in conclusion, you want to learn more about Azure Cosmos DB Gremlin API? These are some of the links that I like to recommend. So Azure Cosmos DB cheat sheets, to keep in a easy way for you to take a look at, okay, how do I do this in this particular API's language? Great support there. Azure Cosmos DB Gremlin graph support and compatibility with Tinkerpop features. This is key because not all of the features that are in Tinkerpop are necessarily going to be in Azure Cosmos DB's Gremlin API. So you need to go to that documentation to see, why isn't my query running this? Oh, it's not supported yet. Practical Gremlin and Apache Tinkerpop tutorial. Great tutorial by Kelvin Lawrence on how to work with Gremlin. Then there's a Gremlin cheat sheet by Daniel Kuppet, which again makes it easier for you to find resources for working with Gremlin and building those Gremlin queries to get what you want out of your graph data. So on this journey, I hope you got to see that there are definitely princesses, dinosaurs, kaiju, aliens, space, and other themes in the Mystery Science Theater 3000 episodes. Thank you for watching, and if you want to get a hold of me, my email is sarah@cleatechconsulting.com. I have a data blog at dataadventurer.com. My traditional dev blog is at saduki.com. I'm Saduki on a lot of social media, so you can find me on Twitter, find me on LinkedIn as well. Thank you for watching, and I hope you enjoy your SciFiDevCon.